Alright, today we're going to talk about the hypotenuse leg triangle congruence theorem. It's very similar to the other triangle congruence theorems we've been doing. Okay, let's first review what a hypotenuse is and what a leg is. These only exist in a right triangle. So the hypotenuse is the side across from the right angle. It's the longest side of a right triangle. The leg is the sides that that are touching the right angle. So this one is the hypotenuse. It's the only one that doesn't touch the right angle. It's across from the right angle. And it's also the longest side. These are legs. This is a leg, and this one is a leg. Okay, those are sides that touch the right angle. Those are what we consider legs. So if it touches it, it's a leg. If it doesn't, it's hypotenuse. So hypotenuse leg theorem in a right triangle, if a hypotenuse and a leg of one triangle are congruent to a hypotenuse and a leg of another triangle, then the two triangles are congruent. So if it was told to you that, for example, this side was congruent to that side, and that one of the legs, say this one, for example, is congruent to its corresponding leg, then you have enough information and you can say the two triangles are congruent to each other. Okay, so here's an example. Segment BA is congruent to segment BC. So if I marked it on here, BA is congruent to BC. And with that information, I'm going to prove that triangle ABD, this left one, is congruent to triangle BCD. So we're going to use hypotenuse leg. You got your statement, your reasons on this side. Let's just start what we know. BA is congruent to BC. Okay, well that was given to us. Is that a hypotenuse or is it a leg? Think about it for a second. Well, that's the hypotenuse, so that takes care of the H. So now we got to prove one of the legs are congruent to each other. But we have no way of saying that AD is congruent to DC. I mean, other than it looks like it. We don't have any markings, we don't have any rules. We don't know that this is the midpoint because that wasn't told to us. But what we do know is that BD is congruent to itself, BD. And as most of you should have recognized by now, this is reflexive property. And so that is a leg. It's the side that touches the right angle. So this is congruent to itself. We got a hypotenuse, we got a leg, we got enough information to say that the triangle ABD is congruent to the other triangle CBD. And the reason is hypotenuse leg. That's it. Okay, so in these you only need to prove two parts, the hypotenuse and a leg, and you're done. Here's another example for you. Segment QR, as it's marked, is congruent to segment SR. And it's also told to you that Q is a right angle and so is S. It's a right angle. Okay, so we could put in our given QR is congruent to RS. Well, that's given. We could say the angle Q is congruent to angle S. Well, it's given that they're both right angles. Okay, so if they're both right angles, they're both congruent to each other. That's my angle symbol. Okay, so this QR congruent to RS, is that a leg or is that a hypotenuse? Okay, that's a leg because it touches the right angle. And because this is true, we know that PR is a hypotenuse. So PR is congruent to PR. Well, let's go ahead and say this. You don't necessarily have to write this part. That PR is a hypotenuse is I'm just going to abbreviate, hypotenuse for lack of space. But you could put that. It might help make the proof make a little bit more sense. And since we know PR is a hypotenuse, that comes from the definition of a hypotenuse. Once again, this line doesn't need to be in there. But once we know that this is hypotenuse, we can say that PR is congruent to PR. Well, this is reflexive property. And now you can say the whole triangle PQR is congruent to the whole triangle PSR. Okay, and the reason being hypotenuse leg. That's it. We've taken care of the leg right there. We know that PR is hypotenuse. We said that it is congruent to itself. We got to have two congruent statements. This one and that one are the key. And now we can say the triangles are congruent to each other. I got one more. If you feel like you're good, you can stop now. Okay, but that's one more. angle VYZ. VYZ is a right angle. Y is the midpoint of VX, this thing right here. And VZ is congruent to WX. So I'm going to go ahead and start with VZ is congruent to WX. And well, why do we know that? That's the given. Is that a hypotenuse or is that a leg? Is that important at all? Well, it turns out that this is a hypotenuse that's across on a right angle. Okay, so H. Okay. This information that VYZ is a right angle. Well, I could have put in here a line before this one that says that WYX is also a right angle because of vertical angles, and therefore this is hypotenuse, and that's hypotenuse. Once again, not really necessary, but it might make the proof flow a little bit better. If you just jump straight to this, I'm going to let that slide. Okay? But if I ask you, how do you know this is hypotenuse? Be sure you can explain that this is a vertical angle with that. They're both right angles, which means that this side is not touching a right angle, it's hypotenuse. This side is not touching a right angle, it's hypotenuse. Okay, so we've taken care of the H. We know that Y is the midpoint of VX. I could write that down if I want. Y is midpoint of, VX. And that means that why that is important is because that says that VY is congruent to XY. Well, what's the reason that's true? Well, if this is the midpoint, then that means this is the definition of midpoint means that it creates two equal segments. Okay? And this takes care of our legs. The legs are the sides that don't touch the that touch the right angle. So you got a hypotenuse, you got a leg. You can say the whole triangle is congruent to the whole triangle. WXY is congruent to CYB. Hypotenuse leg. And that's it. Okay. Please be sure to click on the link at the bottom of this video. Answer the questions so you can get your points. Have a good day.